gentlemen, thank you very much for joining me. For all of our attendees, I'm going to introduce everybody very briefly here. That we have David Walker, who is the field CTO for EMEA for Yugabyte. So I'm going to be looking to David to as my kind of primary reference on what if you like, the Yugabyte party line is. And we also have Frank Pachot, who is community evangelist for Yugabyte. So I'm looking to him to more for, well, what do Yugabyte customers actually do? Never mind what David tells them to do. What are they really doing? And Bart has a similar evangelist role in the Kubernetes community. So I'm hoping that we'll get lots of background of, real world and war stories is what I want to hear. And also from Julian, who is consults heavily in enterprise projects using Kubernetes. So we've got, I hope, good balance here between Yugabyte kind of a product and company versus the Kubernetes community and out there real world. And let me be really clear, the objective, and Julian and Bart have told me this in no uncertain terms before, that this is not about flogging Yugabyte to anybody. This is about people coming away from this and hopefully knowing a little bit more about specifically about stateful applications in Kubernetes and where we are with that and where it's going. And and that's what I'm going to start with. I'm going to start with you, Bart, because from the community perspective. Yeah. What do you see people doing? How do you see people, if like, accessing the data for their Kubernetes applications right now? What's going on out there?
Okay, so in terms of just background as well too, so people can understand a little bit where I'm coming from on this, is leading the data on Kubernetes community, which I've been doing for the last year. And we've done, we're doing our 108th live stream today. So we've been producing a lot of content in that time. Basically, to respond to the question, the very question that you asked is, how are organizations approaching this this challenge, right? Historically speaking, when people talk about Kubernetes, it's assumed that Kubernetes, stateless. Keep your data off Kubernetes, it's not worth it, it's going to be too problematic. Kelsey Hightower for years has been stating that up until this year, when in June he tweeted, and I know that Yugabyte also does like migrations with Oracle, so I'm sure there's plenty of know-how on the Yugabyte side. Kelsey Hightower tweeted about how it was now possible through the El Caro operator to be able to get Oracle databases on Kubernetes. And he himself acknowledging, crossing the chasm, very famous expression of saying there is a paradigm shift here. Going back to what you were asking as well too, is that if we're talking about this for everyone's at a different phase of their Kubernetes journey in terms of adoption, are there really Kubernetes experts out there, considering how young of a technology and how quickly evolving it is? That's a difficult question. But when we're talking about the data questions, a lot of times that's, not even, if we're talking about day 0, day 1, we're talking about day 2 operations. So there's a certain amount of maturity perhaps that might be required when approaching this. But we are seeing, once again, we've had over almost 110 live streams. So, and this is how I know Julian. And we've also had from Yugabyte, had Ameva Narse earlier this year with a very, very interesting live stream. So like I said, because of having more and more of these conversations, and then additionally, I'll probably talk about this later, we did a research report that came out this year where we interviewed over 500 organizations to see how they're approaching this. And the results were quite interesting. We can go into that a little bit later, but there's actually, there are a lot more organizations out there than we realized that are actively running stateful workloads, databases, storage, analytics, lots of different elements of the ecosystem on Kubernetes. So it's very promising to see that, but I think it's important to I want to hear more from David, Frank, and Julian about how they see this as well.
Okay, Julian, I'm going to come to you on that one then. What are your customers doing? How do they connect data to Kubernetes applications?
Well, that's an excellent question. And in order to answer that, I think it's fair to say a bit about the context, because Kubernetes is used in a wide array of scenarios. And the scenarios we are working with is mostly enterprises, large organizations with 10,000s or 100,000s of employees. So they often have large IT organizations. and their use of Kubernetes is different, for example, from smaller organizations. So I'm a CEO of Anyninds. We've been in the data service automation business for quite a while, doing that a lot with virtual machines. So for us, the question is, when is the right time, and is it the right time to bring enterprise customers to use Kubernetes to run their data workloads? And in organizations of that scale, the question always or often is, you want to have data service automation centralized, let's say, for example, in its own subnet or in its own AWS account, where you do, let's say, virtual machine automation, or do you want to have it more decentralized, where you could think of individual business units having a Kubernetes cluster, and then they also run their own data services, for example, in their own Kubernetes cluster. So those are two different models that we often discuss with our clients. Clients with a more central IT approach, they tend to centralize data service automation as well. And that is problematic with Kubernetes to some degree, because a Kubernetes cluster has only a certain extent it can scale to before it becomes problematic. And these large organizations can reach that scale. However, if there's a usage pattern that's more to have self-contained Kubernetes clusters, sometimes even Kubernetes is the only contract you have with infrastructure in those organizations, then Kubernetes based data service automation is actually quite nice, and it has advanced quite a lot. So we personally see it's becoming more popular also because Kubernetes becomes kind of the de facto infrastructure abstraction if you want to keep away from whatever is underneath. And but at the same time, it's not for everyone at this time, but it gets a viable option for sure. And it actually already is.
But you're seeing, when you say not for everyone, but you did talk about large organizations and small organizations. So you think it's about maturity of DevOps and capability rather than anything else, rather than the size of the organization that kind of leads people?
I'll just give you an example at the tip of my head. There's a customer, they run around 3,000 virtual machines running their data services. So it could be anything from Postgres to RabbitMQ, MongoDB, Redis, whatever. So this amount of virtual machines, they're production instances, which means they also have a certain vertical extent and certain vertical scale. So let's say 16 gigabyte of memory each, or decent sizes. So if you try to put that workload into a Kubernetes cluster, I'm not sure whether this is comfortable to do. So maybe you want to split it up into multiple Kubernetes clusters. And that's something that needs to match the way your IT is organized. If that's the case, because, for example, there are individual developer groups and they have the operational capabilities of operating Kubernetes as well as the corresponding operators, that's fine. However, if your IT is organized more centrally, where you want to offer that as a service to your developers, where they don't have to take care of anything, not to scale the Kubernetes cluster so that new data service instances have their place, and not to update the operators and so on, then a more central approach is preferable.
Okay, so it's kind of cultural in a lot of yeah.
That's what I'm trying. That's what I'm trying to point out. The context matters a lot, because on the other end of the spectrum, we have customers who have, let's say, 1,200 Kubernetes clusters. They all look the same, and they use the Kubernetes cluster basically to do tenant isolation. And then a cluster is self-contained, and it's very good to have data in a Kubernetes cluster in those scenarios, for example.
Okay, so Frank, you and Bart were both nodding enthusiastically at what Julian was saying about context and culture. Frank, can I come to you? Do you want to pick up on that?
Yeah. I came very late to Kubernetes because before working at Yugabyte, I was a consultant and I was working mostly with Oracle. And this is not the kind of database that you think to put in containers and Kubernetes for technical reasons, but also licensing reasons. So I came very late, and what I see two advantages when going to Kubernetes. First is the automation, and as you mentioned, Oracle now is doing some operators. Just before, a few months ago, Google Cloud also released some operators to manage Oracle databases. So databases that do not run in containers can be managed and automated by Kubernetes, and that's the first thing. But then there is also the possibility to run in containers, and this is where we see the evolution of databases. And for example, Postgres, that can be done also with orchestration, because you need to control exactly where is the primary, where are the standby. And if you want to upgrade, you need also a lot of control to run the different versions. With Yugabyte, we have more automation in the database, so it's easier to run in the containers. But I really see those two approaches, and this makes it even more difficult for some companies to go there, because some companies are still late in automation.
Yeah,
And
that's
I
like,
think
sorry, go on.
I think you're making a very good point, and which is raising the general question: how should databases be automated nowadays, and what is the role of Kubernetes there? Our learning is that the most important paradigm to choose is on-demand provisioning of dedicated service instances, which means that you provide a self-service to your users, to the application developers, to create their own service instances, which will be represented as dedicated virtual machines or dedicated pods, and they can manage that thing through their own life cycle. And the question is, what is the right technology to do so? And when looking for such a technology, I think it's fair to say it should be declarative by nature, which means you don't want to get into technologies that have an imperative design that will try to execute sequence of commands, assuming there's a certain state of a virtual machine or a container. Is in contrast to that, those declarative approaches, you have either a base virtual machine image or a base container image, and then you do automation on top of that well-known state. And if something like a lifecycle change happens, like an upgrade, you just throw away the ephemeral VM or pod and reconstruct it with, let's say, a newer version of the data service and take care of the data migration. And I think that's the takeaway. This is how you'd like to get it done. And Kubernetes presents a wonderful way to get there. So that's also a bit of context for data service automation in a more general sense that I'd like to highlight. All
right. So Bart, I'm going to ask you for comments on that, because you certainly were quite animated when those guys were talking. So yeah, so this theme of automation, a good level of automation is more important than exactly where the database is, so long as the data services are abstracted. Is that a reasonable way of expressing it?
It is, and it goes back to what was mentioned both by Julian and also by Frank, is this the issue of context and also with culture. And we had a really good speaker once who said that if you only treat Kubernetes as a technical problem, you're going to be missing more than half the battle, because a lot of it is really when we're talking about people and we're talking about culture. And same thing we've heard from SREs, from Google, from plenty of different places. And a lot of this comes down to one of the questions that we ask in all of our live streams towards the end. We try to ask every speaker, why are we not seeing more organizations running their data on Kubernetes nowadays? Is it a technological issue that the technology just isn't up to speed? Is it a staffing issue, meaning that the talent isn't ready to get there? Is it a question of the interoperability of the tools that are available, that things have to be done, tailored to in every single situation, or that we really do have tools that allow us to do this in using across a different stack? Or is it a financial question, which probably applies to all of those? And so I think a lot of what we're going to discover today is that not so much answers about just getting more questions out in the open. And as Julian also mentioned too, you can have a large organization or a small organization, and we've seen that, the adoption in larger as well as smaller organizations. It's mostly just, are the stakeholders that are there ready to make the jump? we talk a lot about, the journey for DBAs in a more traditional role to becoming more SREs, or the term that we see DBRE for database reliability engineer. These are a lot of things that are affecting and shaping that context, as well as the culture that I think every organization has to keep in mind when they're making that transition. We saw this with the cloud. The migration to the cloud it was a mixture of, and still is a mixture of both a technological change as well as a cultural change. And I think Kubernetes is no exception in that sense.
I may have a question there. Do you think people putting databases on Kubernetes are those who already have the application on Kubernetes for 5 years? Or do you see people going to Kubernetes application and database at the same time when going microservices from monolithic, for example?
I'll let Julian jump in on this one too. But what I would say is that you see some organizations that, let's say, when we talk about organizations that are Kubernetes native, that don't have this legacy sort of baggage behind them. And so for them just to jump in directly with and that's one of the reasons as well too, that organizations will say, for reasons of simplicity, to have everything all in the same stack, to have everything all in the same place rather than having things separated, it's simply more productive. So by having everything there, that's what's going to make sense for some organizations. For others, as you said, that have this sort of legacy or getting to this point that feel that they're having to do a lot of heavy lifting in order to get on there, that's where there might be they might be more hesitant. But I would like to hear from Julian on that to see how the organizations that they're working with in NE9s, how they're sort of confronting this challenge.
Yeah, and I'm going to come to you in a moment, Julian. But yeah, David, I'm going to ask you next is, how do you see the adoption cycle in the Yugabyte customers that you're talking to? But Julian, a few comments about that from kind of more general from the community first.
Well, if you think about organizations adopting Kubernetes, you have greenfield development, what Bart mentioned, and you also have those lift and shift applications where you have applications that run somewhere, let's say on physical machines or on virtual machines, and they want to get more benefits from the cloud by wrapping it into, let's say, deployments in Kubernetes. The question is, what is the dependency exactly of this application to be shifted in terms of data services? If this is an Oracle database or a web service or a message queue, the question is, how much effort do you have to write an operator, or is there an operator available? And what's the resulting operational model, which means what do the application developers then have to do with it in order to get the whole system through its life cycle? In my experience, the older, the more legacy the application is, and the more legacy the data service dependencies are, the more likely it is that they will shift the applications first, trying to connect the application to an existing externally managed database first, because they already get some benefit from Kubernetes from that step, and then they approach the database in the next step. However, if the dependency is a database that's already well automated, for example, Postgres, and there's an operator that has a fair operational model that can be easily picked up by such a cross-functional team, then the adoption of Kubernetes can happen much faster. So
David, does that jive with you from the experience of Yugabyte customers?
Yeah, what we see is people who have started on this journey, they've started with typically the first iteration of an organization will have been to move some sort of stateless application across onto Kubernetes. They may then decide to do a complete rewrite for the next generation, or they may decide to move the database that they've already got from wherever it is, Oracle or wherever, to Kubernetes, to run on Kubernetes. And it's when they go through that path that they start to think about what it is. So Postgres is a really good choice, runs on a single pod, you can build a high availability and the clustering around it. But then the challenge becomes all the things that we talked about. How do you consolidate infrastructure? What do you do about multi-clusters and everything else? And what we see is a desire to achieve all of those things that Frank and Julian have been talking about just now, which is infrastructure abstraction, database as a service. So they're looking for cloud native type databases which understand this infrastructure. And that's an evolving space in terms of running these things. So you can move Oracle, but you're not actually getting a lot of that cloud native. It is something being leveraged into that position. You can move Postgres, and that works really well, and it deals with a certain scale, and it gives you some of that infrastructure and automation. But the next thing is, well, how do you spread your database across between multiple, Julian discussed this, multiple Kubernetes clusters? What happens if you want to have the same database distributed across 3 geolocations? How do you deploy those sorts of things? So we're seeing this trend which talks about greater automation, greater database as a service. And we've touched a lot on it. It's about people, skills, and experience. But from a technology point of view, people are now comfortable with Kubernetes. It's been around 3-4 years in terms of stateful sets. But they are moving some of the traditional databases and things there, but that's just moving your problem onto Kubernetes. It's an interesting thing. It's like lift and shift into the cloud. We picked up our Oracle database from on-prem, put it in a VM in the cloud. Now we're doing the next thing. Going to Julian's point, for organizations which are really embedded on becoming this sort of cloud native type database, even if it's on-premise infrastructure, then they are going to make a change to the database services which already have that declarative state, which already have that distributed capability, which can go multi-cluster to provide availability outside regions, all of these sorts of things. So it's a journey, and we quite often encounter customers who've already got to Postgres and they're looking for that Postgres API, but then the distributed geographic nature and things, and all of those automation and declarative states, which is important. So where are we? I think for, Bart talked about the spectrum of people. There are people on the journey, but I think the big picture for me is people looking out to where they should be at the next stage of their iteration. It's not where they are today. Everybody hasn't got there yet. What they are doing is looking for the characteristics, and that's organizational budget, people, all the rest of it, but it's also technology of distributed databases, multi-cloud. One of the things we talk a lot about is concentration risk. So if you've now moved everything to Kubernetes, but you're on a particular cloud vendor, what are you going to do about concentration if you're a bank? Your Kubernetes cluster is now in one cloud. That's not going to be acceptable with concentration risk. So you need to be able to put it in multi-cloud. How do you achieve that with Kubernetes? And answering those problems allows people to move faster to it. So it's about having the infrastructure, the people, and the technology, which is cloud native, to push those things. That's the drivers that we see people coming to us with.
So David, what I think you're saying here is this kind of, there's 2 dimensions of variability here. One is how far people are along their journey toward, well, actually I was going to say towards, but that's the other dimension of the variability, is what exactly do they think their end game is? And do you think there is certainly not, not everybody is at the same point. Like always, the technology adoption is always, a long string of the wagon train heading west. But they're not all going to the same place, you think? The other guys,
No.
yeah.
Sorry.
Sorry, go on. No, crack on. Finish, David. I beg your pardon.
Sorry, no. I was just going to say, Bart touched on this about the similarities with the cloud journey. Lots of people wanted to get to cloud, but they didn't necessarily have an understanding of where that would take them and what where they were going to end up with. The patterns for cloud are now fairly well established. Kubernetes is getting there, but 4 years ago it was stateless applications. Now it's stateful applications with databases underneath it, but they haven't addressed the challenges of concentration risk and all those sorts of things, and distribution. So I think we're yet to finalize on what the working pattern of Kubernetes is to do it, but we're heading in the direction, and we're starting to be able to articulate, like this call today, those patterns that we think that we need to have. So all of us who run the table have been architects in different roles and things over the years, and I'm sure many of the audience have. We're trying to think about where that pattern is. So it's not just that I can get at the engineering team to deploy Kubernetes cluster today, but how will that do the rolling upgrades? How will that be geo-distributed? How will that support ad hoc expansion outside the cluster? All of those sorts of things are the things that are going to be the next thing we worry about. And that drives towards understanding whether the database is something like Oracle, which despite, I grew up on Oracle like everybody else around the table, I suspect. But it's still moving it to the cloud. It's still moving the traditional problem to the cloud, or cloud native, which is going to have those operators built in, that declarative state, all those things. So that, I think that finalizing that pattern is what leads to victory in this battle.
But I'm just, before we go, I want to pick that up with the rest of the panel. But there was one thing that Julian raised, which I did want to ask you about, is about Julian suggested that, if you like, the more legacy, the older the legacy of the start point, then the more likely that it's an evolutionary move the app and then worry about moving the database, as opposed to moving the whole thing in one. Do you see, because I know a lot of Yugabyte customers are already big Postgres users, and for them it will be easier to make the jump in one. But equally, there are quite a few Yugabyte customers coming from places like Oracle. Do you
Postgres is
see
not what
that
I'd
pattern?
consider that kind of legacy.
Yeah. So, David, do you see the similar pattern there? Kind of not exactly a dichotomy, but a weighting.
Yeah, I think people are trying to understand the challenges of what they've got. I mean, if you've got an Oracle database, I was talking with a customer today, they're moving to a big microservices architecture away from an Oracle application. It's a journey, but they've made the big decision. They've made the big decision to say that Kubernetes is their platform of the future. So all the databases, everything that they're building is going to be on Kubernetes. It's a telco for 5G, so it's a huge component about what it is. It's going to have a lot of data, and they're lucky because they've looked at what they did for 4G networks. They've got a big infrastructure. They understand these things, and they've said this time round that final state is going to be distributed databases on Kubernetes with stateless applications sitting on top of that in multiple locations across their geo. But if you are a banking system, which is a core transactional system, and you've got it on a mainframe or an Oracle database, and you haven't got any experience in the team of Kubernetes, then this journey is somewhere else. It's still a journey. They see the vision, but they don't actually know all the right questions that they've got to solve, and that's where developing these patterns comes in and allows them to deliver it. And the communities like Bart runs, the expertise that Julian and people bring into this brings that home. And obviously we let Frank go out and champion it for the developers, I should have said, but it brings home those patterns to do it. And you don't have to do it all in one. You can do it in steps, but it is easier if you have a Postgres database to get onto a distributed database, and it is a little bit hard if you've got to do some PL SQL triggers, and then it's a little bit hard if you've got a COBOL mainframe. But yeah, you can't change where your start point is. You actually, that's the problem. The question is, can you?
But and I'll come back to you, Bart, because you introduced this. Well, I came into this thinking, oh yeah, it's about this journey thing, and you introduced this second dimension about by likening it to cloud migration, which is actually when people started, they thought they were heading for here, but actually when they got there, they realized that was only a staging post, and there's a whole bunch more decisions and actions to take to really exploit cloud native, if you like, architectures. and and that's, that's what you're all nodding furiously as David was talking before about when you were talking about this. So and the key for me on the cloud migrations, it took maybe a decade before before the patterns emerged, as David was saying, before people really understood what they were trying to do with cloud native architectures and what that picture was, the end game. Journeys are going to be different paces and coming from different places. But how quickly do you think with Kubernetes that clarity is emerging? Do you think it's going to be quicker because we're building on cloud, or is this like another dimension entirely? What do you think, Bart?
Oh wow, that's a big question. Talking about
I
big
like the
dimensions.
questions.
Yeah,
You guys do all the talking when it's a big question.
And given my attire, I feel more than equipped to answer it. But I think there are a few different things that you're mentioning there, and that have also been echoed by the group that are good to keep in mind. One of the first things that we had on our website is talking about, Kubernetes has emerged victorious from the battle, because there was this whole thing of, what's going to be the number one container orchestrator. When I first encountered Kubernetes was in 2018, working with a DevOps team, and at that time it was a very strong debate between, is it going to be Apache Mesos or is it going to be Kubernetes? And first it was, the process of learning Docker, containerization, et cetera. But now then we move into orchestration, all the other things that brought with it. So I think that's also what's maybe delayed some of the adoption, was to see, who was going to emerge as the clear winner. It's obvious that it's Kubernetes. Mesos is now in the attic. So I think that was one of the things that perhaps made this go a little bit longer, is that organizations were waiting to see how's this going to go. Then obviously as well too, inside all of that, then we see a lot of organizations going for the OpenShift option for reasons of simplicity. All the support that Red Hat offers behind that as well too. For some organizations, that seems to match up best. Then we get into other cases, as was being mentioned by David, as well as Julian, about seeing classic databases like Postgres but very flexible, battle tested and can be leveraged in lots of different ways. And then seeing how with operators, how then that seems to be, the number one way to get data on Kubernetes as of right now seems to be operators. And it's by no coincidence that today later we're going to be having a chat with one of the principal engineers at Zalando, large e-commerce company all over the world, tons and tons of transactions going on, and how they've been using Postgres and a Postgres operator, Patroni, to be able to get their data onto Kubernetes and what it's been giving them. My sort of additional question on all of this, or that we frequently ask, and I've had the chance to talk to Julian, and Julian actually gave a talk about this in KubeCon earlier this year, is tackling this notion of operators. And will there be other solutions that we can anticipate, and how can we be prepared for them if there will be some say, one operator to rule them all, or that, it wouldn't necessarily have to be something just designed for a specific database, but could have the flexibility to perhaps go between others. Also, there's the issue with operators. Some organizations won't trust a solution that doesn't have more than 2-3 years lifespan on the market. So there's issues of trust. There's also issues, once again, of cost. To build an operator takes time. Does my organization have the necessary skills, the know-how in order to be able to put this together? Once again, we go back to the talent issue. I think this is actually where I'd kind of like to see how Frank sees this as well too, in this, with the folks that he's interacting with, of how they see the potential of operators, also the downsides, the risks, and the adoption period that needs to go into that. But like I said, these questions just bring us to bigger questions, which is what makes this exciting. So we're kind of in this Wild West period where in 5 years from now, we'll say, oh, wow, I can't believe we were doing that back then. Things are much more stable now, or maybe they won't be. But I think that's what makes this.
Jump in there, Bart, please.
Yeah.
One of the things I think is true of this type of technology, and I want to address Dai's question directly, is it going to take 10 years? Yes, there was a hiatus. There's always a sort of skunkworks type underground movement for the first 2 or 3 years of anything out there. But once it becomes the accepted technology, I think Kubernetes is going to be driven much, much faster. And there's a specific reason for that. It's not a major change in that sense. We understand Docker, we understand virtual machines, we've done these things already. There's things to be resolved, but the pace of technology development, the size of the communities that are out there mean that we will get, I think this technology might have a 5 to 7 year, not a 10-year adoption cycle with it, from with these sorts of things. I think we're already down that path. Now, will everybody have finished their migration? No, I mean, there's still people trying to move off mainframes, but will it be, the pattern is established, we know the answers, if you're architecting a new system, this is where you go. Yeah, we're going to get to that much quicker than we did with cloud, because it's not asking fundamental questions that cloud asked, whether it was on-prem or off-prem, whether it was security or whatever. It's a change. This is what we did before. This is virtual machines. These were containers in Docker. Now we're running containers with an orchestration tool. It's the scale of the change, despite everything that we've talked about, is still incremental over some of the big decisions that enterprises have had to make about doing it. So the next things that come are things which are genuinely of interest are going to come not in whether we should containerize and have orchestration and do database as a service and that infrastructure abstraction, but how do we get that to work at the scale that we need with the level of automation that we need for large enterprises? I think that's the biggest challenge.
Yeah, that's absolutely right. And we've been doing that for 7 years now, and we can learn from the journey based on virtual machine-based automation. And one of the things is we see with the microservice-based architectures, the trend to have more databases, more database types, such as Postgres, MySQL, Redis, Rabbit, and MongoDB, and so on, but also more instances. So, and if instances are represented as dedicated instances, there's a large number of dedicated database servers to be operated. And this sheer amount of data service instances to be operated in a self-service fashion, that's one of the transformational challenges these organizations face. And automation can make this transformation, this adoption of those new operational models, more easy. And that's why I said earlier, I believe that the declarative management is there a big step into the right direction, because if you think about the nature of a stateful set, just throwing away a pod and reconstructing it from a known state, that gives predictability. And that's the ingredient that's necessary to run a lot of data service instances, and that, at that horizontal scale. And more than that, once you have that automation, you come into other challenges. For example, you want to minimize the delay between an upstream data service change, for example, a release of Postgres, as well as updating the service instance owned by a particular application developer. And your entire tool chain needs to allow to be efficient about that. This means you need to be quick as the vendor of such automation to pick up the upstream change and release a new automation release. But at the same time, you need to deliver that into the customer's environment. And then the application developers may have to adapt the application because it's a new version of Postgres or whatever. And all that needs to be, a value stream that works like charm. And automation is key to that. And I think Kubernetes does a wonderful job there. But there are some challenges left to be addressed. For example, how do you deal with a lot of Kubernetes clusters? How do you interconnect them systematically while still preserving those workflows?
So, okay, we spent kind of most of our time on ranging across the big questions, and I think that was valuable because it's become when you sit in your own area, you think, oh my God, it's me that I've got these problems, and everybody else is kind of forging ahead, and what really becomes clear to me listening to you guys is no, there are lots of challenges ahead. What I think you're saying is, but if you like, the way to respond to these challenges is also emerging very quickly, and there are best practice emerging, but they are not widely known. They are not universally adopted yet, and I'm sure there's still scope for maturity. So let's kind of spend our last 15 minutes and try and drop down into some specifics where we say, okay, this is the nature of the problem. This is the space in which the solution lies. I don't think, you're not answering, it's not doctor surgery here. You're not diagnosing anybody on in a specific situation, but I'd like to get some kind of classifications and some rules. And I'm going to talk with one question, start with one question that just came up on the chat, which somebody asked was, how do you make decisions, or what are the best practices and the context for where the data is versus where the database compute is? And I think this comes down to this, the local versus remote disks. Anybody want to jump in on that one first?
Yeah, I'd love to.
Good, Julian. Glad you said that. Let's go.
First of all, if you talk about data services, there are several classes of data service. I know immediately two different ones. Let's say Hadoop-like systems where you have the separation of compute and storage, and you often, not always, have specialized hardware, and storage is provided by storage service. They run HDFS and stuff like this, and then you have algorithms that are brought to the storage to those nodes where a particular data partition is you'd like to deal something with. That's for me, from my perspective, that's a different kind of data services. And then there are the classic databases. Originally, they've been operated on a physical machine, and now you put them on a virtual machine or into a container. And in order to make that paradigm of cloud automation viable, you usually have a separation in these systems with into a ephemeral virtual machine or ephemeral pod and a persistent disk that's remotely attached, residing on some remote storage device, storage server, anything. And that is one of the leading paradigms in the automation of those classic databases, although, even if they are more cloud native these days, because it allows you to, let's say, recreate the virtual machine with a newer version of the software, or increase the vertical scale of that virtual machine by reconstructing it efficiently. And I think that's one of the best practices that's absolutely key. But it doesn't apply necessarily to all the data services there are. I was referring to Hadoop as an example. You may also have chances to do it there, but I'm not sure whether it applies there.
I think you've drawn an important distinction. In my mind at the moment, I don't think if I was designing a solution today, I'm ready to put analytical database services at scale. Data marts are fine, but at scale, I don't think I'm ready to put those into Kubernetes. I think that's a difficult challenge with it as a general principle. I think what we're really looking at is where transactional databases sit in there, where they sit behind systems of record, systems of engagement, and systems of reference. Data mart for data science is a good use case, but something like the core data lake technology into a Kubernetes cluster is probably stretching where the technology sits at this point in time. I'm sure that Kubernetes can run all of the pods. I'm just not sure that the databases that support that type of workload will run well on Kubernetes yet. So I think that's an area of maturity there, that I think we're looking at transactional databases, those sort of, as I said, systems of record, systems of engagement and reference, which are the first movers into this space.
I think in this separation, it's important to understand how, let's say we're talking about distributed databases. If we are getting closer to Hadoop or anything, like you have a distributed system and you want to process large amounts of data with it. Then the question is, what is the inner architecture of such a system? And for example, how does it partition and distribute data? And in Hadoop, for example, there's a strong tie to HDFS. So the idea is you store data in a distributed file system, and there are certain decisions are made on how these data is broken down into chunks and how chunks are distributed across the cluster. Now, if you think about other databases that also are able to process large amounts of data, you could also split the data into partitions and then operate several hundred instances of the database in a divide and conquer kind of fashion. So there are two different ways to tackle the problem. And the question is, who has the power to partition and distribute the data? You do that in a distributed file system and get your algorithm to in a scheduler that somehow respects the distribution in the file system? Or do you have a database that partitions data and also knows which nodes have some data and get the compute there? So there are several ways to do that. And to be honest, the Hadoop, is it possible to run Hadoop in Kubernetes, and is that meaningful? I really don't know the answer. I've never thought about this, but I can tell if you have databases that have been designed to run locally, they can be put into a cloud with this ephemeral VM and persistent disk kind of pattern. And you can construct distributed systems from them. And that's happened to a lot of classic databases. And they live well as cloud native databases if they are refactored to a certain degree and enhanced.
And this, I have to jump in with a party line. I mean, I think you're right. You can construct that to work well. You can take Postgres and do these things. But the next generation of moving to these ones is about having that done for you. It's not about you constructing it. The next generation of distributed databases are cloud native. They were born in the cloud. That's what I mean. Yes. Yeah, I think that's where we can see the cloud vendors trying to do this with some of their databases where they're doing it. We're obviously, as a company, we're very engaged in running major clients on Kubernetes with that, but it's this bringing that infrastructure, bringing that, exactly what you say. You don't want people to have to do the work. We're trying to simplify. You've touched on all the key points. If you're going to run thousands of instances, if you're going to run that in distributed with stateful sets, you do not want to be constructing it. The word constructing implies that. May I
ask you a question here, because you're raising a very good point. And what I'm trying to get across is that automation and the design of the database, it comes closer together, which means when I say constructing is, I think about, you have automation that, you can apply to Postgres, but at some point, you want to have a database that does certain things in a cloud native way. So automation and the code of the database, I think they're getting so close that at some point they're just, part of the product. It's not that the automation remains forever an exoskeleton that's wrapped around a piece of database.
Sorry, go on. You finished, David.
Yeah, this is where, if you talk to our founder and group CTO, Karthik, he's absolutely on this. He came out of Facebook, where they were running lots of databases, a super-sized scale with these things. And he goes about this. The design is fundamental. Cloud native databases are an evolution from databases. I'll pull on the same word, constructed. We're not constructing something. We have built something which has those two things tightly coupled. It has the service and the automation and the infrastructure, everything that you need to operate as a database as a service tightly brought together. So your question, which I think is a valid one, is, are these things coming together? And I think the answer is, for the leaders in this segment, in this distributed SQL, they have had to come together, because that is a definition for me of what cloud native database is: to be able to automate, to be able to spin it up, to be able to offer that database as service. And there are players out there. We're not the only people in the market, but this is definitely a trend which we see with distributed SQL, is bringing this cloud native technology to a container management system. And as Bart has said, Kubernetes is the winner. So we are driving towards the answer to the question. It is cloud native, it's distributed, it has done all of those sorts of things. It's available now, and it is going to run in Kubernetes.
Maybe just one quick thing, because this also answers you mentioned the user usually asks if they have to put the database on a local storage or a volume outside. And this answers in some way that you have the choice depending on what you want to do. With a distributed database, you can put the database on local storage because you have replication. Doesn't mean that you have to, because probably you depending on your data, probably you want a persistent volume where a pod can be down and up and getting the same data. But being cloud native allows also to do that because you have the replication within the database.
So to summarize that,
may I
Julian,
say
go on.
something about this for
Sure.
a second?
But I do
You're
want to
absolutely
summarize.
right. Let's assume you have a database that has about, let's say, 0.5 terabyte of data, and you want to go through a version upgrade of that service instance. In that case, if you have a persistent disk that will survive the recreation of the pod, all you have to do is reattach the pod and maybe catch up with replication for the little data delta that has been missed during the outage, the planned switch over within the upgrade. If you don't do that, you'd have to replicate the entire data set, which will take a lot of time. So in this case, the question whether you want to have persistent volumes or not is also related to the question, what is your intended time to repair or the intended runtime of a particular lifecycle use case, such as a vertical scale out or such as upgrade.
Yeah, that was where I was going with that question, because I mean I've been reading in prep for this and about this debate about whether you can use local disk and rely on the database to partition so that if you do an upgrade, you take out pods and you replace each one, and each one has to do their own replication. If that is kind of native functionality to the database, you can do that. My question would be, David, is my understanding of that is, yes, there's going to be some lag because you're recreating lost data, even though it's partitioned and no one place has to replicate the whole 0.5 terabyte, for example. But what's your answer to Julian's question or Julian's assertion there?
Yeah, I am absolutely convinced that we're pushing this up to the right level. So I think local disk, and we can rely on it. It will catch up. It's about the scale that you build this thing at. There, so you have as many components that can fail as possible, because failure is inevitable. And you should be able to have this abstracted so that you trust local disk, so that you're able to deploy these components and let them sort themselves out, because they have these quorums over where the data is, they have the replication, the consensus algorithms. You shouldn't worry about that. That should be hidden behind the scenes from what you're doing. And it should, the vendors of the database technology, and it should just deliver the service. It's not about architecting it. We want to deliver the service. So we have to build systems where you trust it to replicate on local disks, to spin up the extra pod if it needs it, whatever it takes to give that reliability, that resilience. And that's the goal, is to build systems which are automated to that level, that they provide that sort of context.
And that's kind of, and really what I think that, if you like, the dichotomy here, the balance is that if you're doing this on traditional databases, even fairly modern databases like Postgres, then you really don't have a great deal of option apart from you're going to have remote persistent storage. And what you're saying, David, is, well, actually, if you've got cloud native, highly distributed, highly replicated database, that isn't your only option. It may still be the right option, either for cultural reasons. We heard a lot about this, about where you're coming from, the capability of your organization. But if you are what you would say to Yugabyte customers, maybe not many other people would have this option, or could sensibly consider this option. What you would say is, no, you should be looking at this. It may not be right for all of your apps. It may not be right immediately, but this is certainly something you could do. And sorry, I have one last question I wanted to sum up on, because it gives me a lead in for our next webinar. But I wanted to come back to you, Bart and Frank, because you got frozen out for the last 10 minutes as these two guys who are on my screen, they're on either side. So they're like, I'm seeing them. I just want to give you guys just a minute to sum up, if you like, what you feel are the important things that come out today. Bart.
Frank? Okay, okay. Well, I think
Sorry,
I think there are a lot of, I think obviously there is a lot. And once again, having had quite a few conversations, this is particularly stimulating to see where everybody's at on this. But I think what we do agree on, and because David mentioned this, is that, you know, we're in a time frame of several years that still need to, you know, move forward in order to have clear conclusions about this. That being said, I touched on this earlier, but we did interview 500 different organizations this year
Yes,
and got their opinions about how they see the challenges, the opportunities of running data on Kubernetes. And 90% of these 500 organizations said that they think that Kubernetes is ready for stateful workloads, and 70% were already running Kubernetes in production. So there is maybe more behind the scenes going on than we might realize, which then makes us ask, how can we get these conversations out more in the open? But that's exactly what we're doing right now. If you want to take a look, I will drop the link here. You don't need to give an email or anything. You can download the report directly. But I think it gets us to get the further questions out that will help us to have more conversations. So I'd like to know when we're going to have the next one.
Well,
Thank you. Frank, quick summary.
Yeah, more conversations. That's the best way, and hopefully people who already went to put databases on Kubernetes, please share it at conferences, blog about it, because there are people who really lag in this idea, and they will have to catch up. So getting more comfort from the experience from the other is really important.
Yeah, maybe despite the lots of conversation and lots of difference of opinions, actually there is more maturity than we think. But if that survey is right, and I'm going to wrap up now because we've gone 11. I'm going to say, firstly, gentlemen, thank you very much for your time and for the insights. It's been great. And I just want to pick up one last question off the chat where somebody said, would we need different system capabilities to satisfy different data requirements in the future? And I'm not going to ask you guys to answer that question. So all I'm going to say is to the asker of that question is watch this space, because the idea of the heterogeneous data layer that has different kinds of data management capabilities for different applications, I think is exactly where it's going to where we're going to go. And that will be the subject of one of our tech webinars in the coming months. Meanwhile, thank you to all the attendees. Thank you to the panel. Season's greeting, Merry Christmas, whatever it is. Happy holidays. And we'll see you all next time, I hope. Thanks very much. Bye now.
Bye-bye. Thanks for having me.
Thank you.